guys, it's Mr. Flanagan here to help you out a little bit. I know we're starting classes in objects soon, or maybe you've already started them, and I just wanted to have a video out here so you could see what they are and how to use them and show you some examples of how we might be using these things. So you've probably heard of these words at least, classes and objects, and I'm going to show you the class syntax right here. And here's the slideshow for it. This is on Schoology. Hopefully you are able to see that there. So class syntax, this is the very basic form of it, where you have the class name and then the name of the class that you want with a left and right bracket to close in what's in the class. And for our purposes, we're going to have a bunch of methods and variables inside of our classes. Here's an example of just a setup. We have the example of class, and this is shape. So class is the declaration of we're going to start a class, and shape is the name of that class. And we've seen these before, but while we've been doing Java, we've exclusively used this object-oriented programming language Java, and all code placed in a class declaration. All our code has been forever. And the first method is called the main method. That can be in its own file. So what are classes? They pull together related data. So it's like a blueprint. So if you have a class shape, shapes have an X and a Y, like where they are on a coordinate plane, where a width and a height, how wide and high they are. So all shapes have this in common, no matter what shape they might be. So you could also think of this as like a car. Well, all cars have a couple things in common. They have a color, they have a weight, they have a number of wheels, a number of axles, a number of windows, if their windows are tinted or not. And there's plenty of things that all cars share, so that they could all be formed in a class. So we associate them with methods. So let's talk about the shape real quick. So our class is shape. All shapes have, again, X, Y, width, and height. So we've declared that they have an X, a Y, a width, and a height here on this line. We'll make sure you have that semicolon at the end. And now we're going to create a method for what the shape can do. So some action this shape can take. If it was a car, you might have like a drive method or a honk the horn method. But as far as the shape is concerned, we have these two methods here. We have the first one, which is move right. This move right method allows the shape to, let's see, take our X value and make it X plus 20. What does that do? It increases the X value by 20. So if it started at 50, now it's at 70. If it's at 100, now it's at 120. And there's the grow method, which uses the width and the height, which increases them both by 20. Again, if they start at 0, they're both at 20 now. And if they start at 100 each, that'd be 120 and 120. And you can make them different as well. So right now we see a class showing what variables we're going to use in that class, x, y, width, and height. And right now we have the move right and the grow methods, the two different actions this could take. Now you can see that we haven't used y yet, and that's okay. You can add things in here and not use them yet, and it won't give you a problem. So let's look now. We have an object of a class inside of another class. So let's look at this one right here. We have this class location. And in this class location, we have just the x and the y. So we've declared an x and a y. And we have that movement, move right method of x equals x plus 20. Now, we've already declared that class, but we have another class over here, class shape. So we have, right here, we just did int and height, the int with width and height, and then the location of the location. We have the void move right now. So this location, the location thing right here is using this class right here that we've already created, location, the location. We have the right, which takes the location that we're using for this shape and moving it right. And the grow is the exact same thing because that's just declared straight inside the shape. And there's something private versus public. And you can think about that as all class variables and methods have to be either public or private, also protected, but we won't see that very often, at least in our class right now. All variables should be made either private or protected. For our case, they're going to be private for us, just make them private. This is needed so that objects do not behave such that the programmer hasn't defined. So let's say, for example, we messed up and we made it public and we changed it somewhere. We don't want that to happen. So for now, let's just keep them private. It also helps protect access to various information, and variables can still be changed inside the methods after we define them. So just make them private for now, and we can change them inside of our methods. So we can see some private versus public stuff right here. We see that we have private declaration here and here. We have a public here. What if you can see the difference between, here's private, here's public? We can see this is declaring some sort of variable with width and height or location, but this is a method, so you can keep the methods public, so you can use them over without having to redeclare them. And we have void move right, so it moves location move right, and void grow, changing the width and the height by 20 each. So the big thing here is that you want to keep your declaration of variables private, but your methods public. And we have this idea of the class being a blueprint again, where we have a class that only tells the computer what goes into the object when constructed and how it behaves. It's like a blueprint. So like all houses have doors and windows, just where do they go and how big are they and what shape are they? Those things can change. In order to use it, we have to use the new operator. So example, if we wanted to create a new robot, so we have this robot class, this robot blueprint, but we want to create an instance of it, like an actual robot. Instead of just the blueprint, we want the robot itself. We have to say robot, the name of the class, Bob, the name of the object. This can be almost anything. And then equals new being the creation of the object, and robot being the name of the class, and then a left parenthesis, right parenthesis, and a semicolon. This will create a new object. And color background, you've seen this a little bit before. So again, name of the class, the name we want it to be, so background, so we're trying to look at the background here, equals new, and then we're doing the same thing as here, color, same in the name of the class. And then this right here are the different RGB values of that color. And we actually used that one before when we were doing the flags. And we have the constructor. It's a method that is called whenever the object is created using a new operator. It has the exact same name as the class. So let's say if the class is named time, then this method is also going to be named time. In it, you should set up variables and whatever else is needed anytime an object of the class is created. So let's say I need to use like hour, minute, and second when I make time, and you'll see that coming up pretty soon. This is where I would put hour, minute, and time. Sorry, hour, minute, and second. My bad. But that's this constructor method. Just like any other method, it can take in variables, and if you do not provide one, Java will provide one for you, even if it does nothing. C++ also does this. So let's look at this constructor method. So again, we see the shape class, private int width and height with a private location, the location, with a public shape. Okay, so this is where we get into that constructor idea, where we have the public shape, so it's the same name here and here, and we have int x, int y, int a width, and int a height. So what these things do are they're showing that we're going to be using x, y, width, and height. So we have the location equals new location. Remember, we've already done this. We've already created this class. And this location right here is we are constructing which location is going to be at. So we have to fill in the x and the y because location needs x and y to create. And then width equals a width and height equals a height. You can see that height and width have different names. We put that a here to have different names. Then we have the public void move right. This is the same method that we've seen before, and the public void grow, we've already seen this one as well. So the big thing here with the constructor is that we are constructing an actual object here. Cool. If we want to refer to something else, when you declare an object in Java, you're only creating a reference to that object. it's kind of like declaring an address that gives a location for something. So it's like it points to somewhere on your computer. That is why we have to create an object using the new operator. If you want to create an object and assign it to an object name, then the old object is no longer referenced and Java will delete it. An object can refer to itself using the keyword this. So it'd be like this dot minute or like this dot first name. Class variables versus method variable. So a variable declared inside a class can be accessed by anywhere inside that class. So if you start with the class, like class shape, and we declared like X and Y there, or height and width, it can be used anywhere in all the methods. Variables declared inside a method can only be accessed inside that method specifically, and no longer can exist once the method finishes executing. So you want to make sure that if you want to use a variable over and over and over again, you want to be able to put that in the class, not the method. But if you want to use it just in the method, you put it in the method. There can be a class variable and a method variable with the exact same name, actually. That should be avoided. But if it does happen, the class variable can be referred to using the this, like we talked about before, like this minute, followed by the class variable name. So here's a class constructor so you can see it. We see the same thing as before, but now we have this dot width and this dot height. This shows that this is a specific object that we want to use, like this shape. And you can see everything else is exactly the same. Now, we've used double equal sign before to show things are equal to each other, but that's not going to fly when it comes to comparing objects because they're a little bit too complicated. So objects are complex things. You can't compare them just using the double equal. Java will let you, but double equal will not compare the objects themselves, but instead check that they reference the same location in memory. So when checking equality, it's like you're checking equality of two different objects, you want to use the dot equals method. And that's going to be it. I'm going to have a video showing the next thing pretty soon, an example of the time method and time class. So stay tuned for that. I will see you very soon. Bye.